Okay, hello ladies and gentlemen, and I hope you're doing well. Welcome to our next session. In this session, it's going to be a solving session. I'm going to stress solving some problems, starting from section 3.3 up to section 3.6. We'll see how long that will take, and we will accordingly classify them into tomorrow and after tomorrow, hopefully. That is Tuesday and Wednesday. Let's start with question number 25. The questions from 25 to 34 in section 3.3 are the ones that are really important, and the others, it just gives you a way to solve for critical numbers. It's just a practice on how to get critical numbers. So you can, if you have time, of course, sit and do them. But from 25 to 24, they cover the idea of find the absolute extrema of the given function on the indicated interval. So find the absolute extrema of the given function on the given interval. It's very important to remember we're talking here about absolute extrema, which means that we zoom out and we look at the function over all the interval given, and we find that one particular value that is the absolute maximum value, and that one particular value that is the absolute minimum value if they exist. So let's start with working with number 25. I will choose a couple of examples. First, of course, is always a polynomial, x cubed minus 3x plus 1. See, if I want to study this, of course, I need an interval. If you remember, this is where we have to remember what governs solving such problems. What governs solving such problems is the extreme value theorem, which said if f is a continuous function over a closed interval, then f attains an absolute max and an absolute min over that interval. And how do we find that absolute max or absolute min? What are our options that we look at? The options that we look at are the endpoints of the interval a and b, and the critical points that we find, which we usually call C1, C2, and so on. So over here, this is f of x is continuous over the closed interval from 0 to 2. Alright, which means that it attains its absolute max and absolute min. How do we find that absolute max and absolute min? I look at the options. What are my options? My options of x are first the endpoints, which are 0 and 2. Then I need to search for my critical points. To find the critical values or the critical points, what do I need to do? I need to find the derivative. The derivative is 3x squared minus 3, which is 3 into x squared minus 1. This is equal to 0, 1, x equals plus or minus 1. This is undefined because we never forget that critical values have to involve also f prime undefined. Because we are dealing with polynomials, this is not applicable. So how many critical values does this function have? Only 2. Plus and minus 1. See, I don't take them both and I just put plus and minus 1 here. It will be wrong. Why? Because what is the interval you are working with? From 0 to 2. Plus and minus 1 does not both belong to 0 to 2. What is the only value that belongs to from 0 to 2? X equals 1 is the only one from 0 to 2. Minus 1 is less than 0. It does not belong to this interval. So what's my third option? X equals 1. Now, how do I know which one is the absolute max and the absolute min? Since I know for sure one of these should be my options, I get the y value by taking f and evaluating it at 0. F at 0 is equal to 0 minus 0 plus 1, 1. F at 2 is equal to 8 minus 6, 2 plus 1, 3. And f at 1 is equal to 1 minus 3 minus 2 plus 1 is minus 1. If you notice between those three values, this over here has the highest value, so this is our absolute maximum, and this over here has the lowest value, so we call it our absolute minimum. I want your answer to be in a formal manner in the end, so you write here conclusion. The point 2, 3 is our absolute maximum point, and the point 1 minus 1 is the absolute minimum point of the function f of x equals x cubed minus 3x plus 1 over the interval from 0 to 2. All right? Now, in the same example, if you notice, in part B, they change only the interval. The function stays the same. So in part B, for the same example, in part B, they change the interval into from minus 3 to 2. What does that change from the previous work that we have done? The options change. See, what are the x values now that are our options? Minus 3 and 2 because they are endpoints. And what else? The critical numbers. Do I need to do the study of the critical numbers all over again? Of course not. When I did the study and it turned out that my critical numbers are plus and minus 1. But I only used x equals 1 because the interval was from 0 to 2. Now when my interval changed to minus 3 and 2, I can take the minus 1 and the 1 both. And then I compare. So minus 1 and 1 are both taken into consideration. The critical values that we need to take into consideration are both plus and minus 1 because both of them are in which interval? Belong to the interval from minus 3 to 2. Then I calculate f at minus 3, which is equal to minus 27 plus 9 minus 18 plus 1 minus 17. F at 2, we already calculated it before, it turned out to be 3. F at minus 1 is equal to minus 1 plus 3, 2 plus 1, 3. And f at 1, which is 1 minus 3 minus 2 plus 1 minus 1. This being said, I look at those numbers and compare them. This over here is my absolute min. And these over here both have the same value. They are my absolute maximum value. So what is the conclusion for part B? The conclusion for part B is that f has, if you want another way to write things, has an absolute minimum value of minus 17 at x equals minus 3, and f has an absolute maximum value of 3 at x equals 2 and minus 1. So one absolute maximum value, not two. One absolute maximum value which is equal to 3. But this 3 is attained 2 times, one at x equals 2 and the other at x equals minus 1. All right, this over here covers for me one question. I'm going to do another question on this involving number 27. F of x equals x to the power 2 over 3. Again, we want to find from minus 4 to minus 2, we want to find the absolute extreme values. This is a continuous function because it's defined everywhere over all real numbers, and it's continuous over all real numbers because this is the cube root function. And this is a closed interval, which means by the extreme value theorem, this function attains its maximum and minimum over this interval. And what are my options? The x can be minus 4 and minus 2. These are my endpoints. What do I also look for? I look for critical values. To find critical values, I need the derivative function. The derivative function is 2 over 3 x to the power 2 over 3 minus 1, which is 2 over 3 x to the power 1 over 3. When is this function equal to 0? Never, because a fraction is equal to 0 when the numerator is equal to 0, which is here not applicable. When is this undefined? At x equals 0. But x equals 0 is not in the domain from -4 to -2, where the interval that I'm working with. So do we have any critical values that I will take into consideration? No. So what are only my two options for max and min? -4 and -2. Here I get cube root of 16 of -16, and here I get cube root of 4. Cube root here of 16, and here cube root of 4. Which one is bigger? Of course, this is bigger, and this is smaller. So my conclusion would be f has an absolute maximum point, which is -4 cube root of 16, and absolute minimum point, which is -2 and cube root of 4. Now for the same function, but take another interval, which is from -1 to 3. What differs is that now my options include the endpoints which change. They are -1, 3 now. They are not -4, 2 anymore. And now what do we have to add to those options? The undefined value, which is 0, because 0 belongs to -1 and 3. Y is what? It's the cube root of 1, 1. It's the cube root of 9. And here the cube root of 0. How am I calculating this? This is the cube root of the square of x. So you square x, then you take the cube root. So I squared x, then I took the cube root. Squared -1, 1 cube root, again 1. So which one is the max? This. And which one is the min? And this is neither. So f over this interval now has an absolute maximum point that is 3 cube root of 9, and f has an absolute minimum point, which is 0, 0. All right, so this is what we have over here. There are functions that look like number 28. I'm just going to give hints. I'm not going to solve the whole problem because here it's redundant, so I'll be repeating myself. But just because some students, they look at the function and they find it hard to find zeros when it's involving trig functions. See, when we get f prime of x, this gives me cosine x minus sine x. I want to solve for critical values, so I want f prime of x equal to 0. So I want to solve cosine x minus sine x is equal to 0. Many students would find this very hard, but this is the same as saying cosine x has to be equal to sine x, which means tan x has to be equal to 1, because we divide by cosine x both sides. So we get tan x is equal to 1. If tan x is equal to 1, what are the x values allowed? It's pi over 4 plus k pi, because then you repeat yourself. They have the same tangent values. So this just for you to have an idea on how this is done for problems like these. All right. Thank you so much. This is the first set of exercises for section 3.3. What comes next is some exercises for section 3.5.